Okay, so this work was done as part of Jason Carter's thesis, and he's off in industry doing real work, so I'm the one who gets to present this paper. So to put this paper in the context of this conference, I'm going to use a much more general definition of emotion uh, uh, than what I've seen before in the previous talks. I'm going to assume that it is any aspect of user state. Okay, and there's many aspects of user state that people have studied, and what we are focusing on is programming difficulty, okay, and difficulty during activity, not after activity. And here I've listed a bunch of other related work, and as you can see, we are the only ones really focusing on inferring programming difficulty during activity rather than code comprehension after difficulty, after the activity, and so forth. And so one of the reasons I'm here at this workshop is to try to get more people involved in this area, especially those of you who are PhD students here. And what excites us about this particular problem is the application. You can use it to provide remote help. Okay? And the system I've described here works as follows: that if somebody's in difficulty, somehow by magic, I'm not going to talk about how, the difficulty is detected and is communicated to somebody else who can then share the screen to help solve the problem. Okay? So the question that we haven't addressed so far, and which is the focus of this particular talk, is when the remote helper, potential helper, gets a notification, how do they determine if they can help and if they should help? Okay? And to answer this question, they need to know how the person who's in difficulty got there. Okay? So to answer this question, I'm also going to talk about meetings. Sorry, I've got ahead a little bit. So the question said here is that what kind of context should be accompany difficulty inference? Okay, and to answer this question, I'm going to talk about meetings, but about a different aspect than what we heard in the previous talk, which is the latecomer problem. That how does a new person get up to speed with what has happened so far? Okay. The classic solution there is to replay the activities that occurred that the person had missed. Okay, and what I show here is work from Microsoft Research, a system called AIR that Sasha Junazovic helped build, who was a student of mine, and it's a classic solution, and there's the state-of-the-art artwork in this area, which is to basically replay the activities that occurred before. Okay? So it seems that we can use the solution in our problem too, except that there are a few differences. In the classic scenario, we are assuming that the meeting started with at least two people, okay? And somebody then joined later. In our scenario, the meeting, quote unquote meeting that somebody's joining, involved only one person, and somebody's joining at that stage. Okay, so in the classic scenario, latecomer joins what is a non-private multi-person interaction at a scheduled time, whereas in our scenario, somebody joins a one-person interactive session that was more private than the one that is in the classic scenario. Okay, and because there was only one person involved, we had no audio, no text, no chat, no video to record, and all we have is the workspace. Okay, so we are working a little bit in a little bit more limited situation here, and we also don't know how much of the workspace to record because this occurred at an unscheduled time. The latecomer's task is to assimilate information. Okay, so the metric is how much information could the person recall. In the case of our interaction, the latecomer's task is to help solve the problem. Okay, and the metrics are how correctly can they solve the problem and how much effort was involved in solving the problem. So the situation is similar but not quite identical. Okay. And talking with the metrics, these two metrics conflict with each other. The more effort you apply, the more correctly you can solve the problem. And you can devise solutions that optimize on one and not the other. So what you see here are two user interfaces we created. One is a more traditional user interface where you can play and rewind the recorded interaction. So you can take your time and get it correct. And the other one says, let's just try to see what we can do quickly. So there's no replay and there's no play and pause. You just get one pass through the recorded context and see, and you determine whether you can solve the problem or not. Okay, so there's single pass and multi-pass. So if we want to figure out which is better, or if any of them is good, we need an experiment. And the question is, what kind of experiment should we perform? Again, we'll go and look at what was done at MSR, where they recorded a bunch of meetings and had the same subjects, the multiple subjects look at the same meeting recording and evaluate how well the subjects did. Okay. So in our case, we can again record somebody's difficulty session, one or more persons' difficulty session, and have multiple experts try to figure out whether they can resolve the difficulties using different kinds of context. One issue that we face that is not faced in the latecomer problem is that the interaction is asymmetric, that the person who's helping is an expert and they're supposed to have the expertise to solve the problem. So if you're going to have a lab study, how do you make certain subjects experts in other people's problems? Okay, so that was one problem, that was an issue we faced. And to solve the problem, we ran our lab study in 2 phases. Okay? In the first phase, we had a bunch of subjects solve problems, the same problem. Okay, this is the developer phase. And then a month later, they returned. Now they were experts in the problems. And what they did was, they evaluated, they helped solve difficulties of everybody else but themselves. Okay, so this person created a set of difficulties here. This person did not help solve those difficulties, but the others helped solve the difficulties this person faced. And of course, we did this for each recording session. Okay, so we had a bunch of sub-experiments where developers became experts on other people's problems. And this kind of experimentation, for those of you who do machine learning, is similar to taking a bunch of data and running multiple sub-experiments on that data by considering some data to be training data, some to be experimental data, and then in other sub-experiments, you change the roles of the training and the test data. Okay? Here we change the roles of not the data, but the roles of the users. So they become developers in one phase and experts in the other phase. So in the experiment that we are reporting here, we had 14 subjects, 9 student programmers who had interned at industry, and 5 industrial programmers. And in the expert phase, not everybody returned. So 10 of the 14 participants returned back. Okay, so those are the 2 phases we had. And what we did was, like I said, one doesn't know when somebody will face difficulty. So when difficulty is detected, we go and record the 5 minutes of interaction before the difficulty occurred. So we had 2 situations. One was a single pass tool. The other was the multi-pass tool with the play and pause. And in both cases, they had 5 minutes of the recordings shown to the people who returned. Okay, and then to evaluate the multi-pass and the single pass mechanism, we randomly assigned the experts to one of the 2 conditions. Okay. So another issue is what kind of problems are they solving? Okay, we want the problems to be not impossible, but not trivial either. You know, I work too hard, and I have to remind myself to take breaks. So okay, it won't happen in 45 more minutes. So I thought Microsoft had some mechanism where these things automatically get turned off, but I guess it's not on here. So what we did was we chose problems from ACM programming context, and we took some simple problems, some medium complexity problems, and some hard problems. And you see here the difficulty level the difficulty level here is the percentage of people who've got the problem correct. And we also are looking at difficulty, but we're not looking at aggregated difficulty. We're looking at individual difficulty as it occurs. Okay. So the question is, how did we actually figure out difficulty? And what is difficulty? So difficulty in our scenario means slower than normal progress. Okay. It might be a temporary difficulty where you think you're facing difficulty and then you overcome it, or it might be a more permanent difficulty where you switch to another problem. Nothing is really permanent. I mean, given enough time, a lot of problems can be solved. So what we are saying is that people just felt that they couldn't solve the problem given the constraints of time. Okay. And how did we go and get the ground truth? So we have a tool that predicts difficulty. It's sometimes correct, sometimes it's not correct. So we had the tool predict difficulty, and the developers could correct their status. And in addition, Jason manually looked at the screens to figure out whether they were facing difficulty according to him. And the screens were recorded. And after the session was complete, we asked them to confirm the inferred difficulties through JSON or to the system, and that confirmed status was considered ground truth. Okay. So from this, we had 16 permanent, temporary and permanent difficulties, and one of them was used for training in the tool. So they worked with 15 of these difficulties. So what did they actually do? What did the experts? So in the developer phase, it's clear they just solved the problems, okay, and they corrected the difficulties. In the expert phase, they looked at the difficulties of others and outlined how they would solve the problem. Okay, so this was our task, not to recall information, but to actually see whether they could, with the context that was given to them, solve the problem. Okay, and then we had two coders determine if they had solved the problems correctly or not. Okay, so it's somebody to go and evaluate the experts also. And they work with a rubric. So here are results. Not surprisingly, in the multi-pass situation, more problems are solved correctly. Okay. And also, it was interesting that if you combine the two conditions, about 50% of the problems were solved. Okay. And you can look at it as a glass half full or glass half empty. Okay. Glass half empty, you can say that half the time offering help is a waste of time. Okay. If it is, it's good you had context. Okay. So it's good that you use the context to determine if you can help or not, and didn't go and bother somebody else and say, oh, sorry, I couldn't help you anyway. And with the glass half full, you can say that with 5 minutes of context, 50% of the problem was solved. That's pretty good. Okay. So the next question then is, besides looking, what was the overall time spent on the difficulty besides looking at the context? And in the multipass case, more time was spent, again, not surprisingly. And the reason they spent more time was because they wanted to make sure they were giving the right advice. And here are some comments to show why they used multipass mechanisms. Okay, and they were also asked to evaluate which mechanism they preferred, and they overwhelmingly preferred the multipass mechanism. Okay. Also, it's interesting to compare the time the expert spent on the difficulties, solving difficulties, as opposed to the person in difficulty. Like I said, some of these difficulties were temporary, so developers did overcome them later. So the ones that developers overcame, how much time did they spend, and how much time did the experts spend? And the experts actually spent less time with the context they had. So that's actually consistent, and this is not surprising because many of the about 90% of the problems required only one-line fixes. Okay, so that's why the time was small. And there's lots of sorry, I guess I can't go back. There's lots of previous work that shows that when people help each other, the overall productivity increases. And these results show at a micro scale why that happens, because another set of eyes can quickly find the difficulties. Okay, so to summarize, Providing unscheduled help is similar but not identical to the latecomer problem. And we had two choices there. Multipass was a single pass. There's many choices. We looked at two choices. And if you're going to evaluate multiple choices in this situation, you need to, one way to do that is to have this two-phase experiment. And the metrics that you might use are correctness, time, relative to developer, number of online fixes, subjective evaluation. And as in the previous talk, I want to say the results are probably the least interesting part of the whole talk here. What's more interesting is the framework, because the results are very problem specific, and this is one experiment. So that's why we need more work along these lines. And so the overall message is that difficulty triggered help and contextualized replays are promising research. Hopefully I didn't. Oh, thank you. Yeah.
I have two questions about how you conducted the experiments. How did you measure, as far as I have understood, there's some kind of programming task these developers are doing, and afterwards they're stuck in a difficulty and they try to solve that difficulty. So how did you measure the time, given that, how did you detect that they got stuck into a difficulty and they tried to solve? Because there is a development time that they spend, and from there, somewhere in the middle, they get stuck and they try to solve something.
Right. How did we actually measure this time?
That period.
Yeah, and to be very honest, I didn't do this. Jason did it. But the way I believe it worked was that our tool detects when somebody's facing difficulty. Okay, our tool, every 50 commands, it goes and makes a prediction whether somebody's facing difficulty or not. Okay, so we know. Did I go too fast?
No, I'm saying it's in Jason's dissertation.
Oh, yeah. But no. But let me.
Algorithm.
Okay.
Yeah. No. So that's the algorithm.
Okay, great.
And no, but that still doesn't answer your question completely. So let me.
No, I can have a look at it.
And then the basic idea is that we've got recorded sessions,
You were kidding?
and they're recorded sessions, and you can go and have a coder see where the problem occurred around that point, and see at what point the problem went away. There were only 15 difficulties. There were 40 hours of interaction, but only 15 difficulties.
Okay. The second question is, why did you turn the video off? Maybe the face expressions might also give clue about.
Okay, so I didn't even tell you how difficulty was detected. I have not told you how difficulty was detected, right? Whether we used faces, whether we used anything, it's all magic right here. We use all of these mechanisms. Okay?
Yeah, but,
So,
this
but I didn't turn.
question.
Sorry. What video did we turn off? We didn't turn off any video.
You said that in the meeting, because the tool that you use is using in a meeting session, and in the meeting session there's audio, text. You are using all the channels and also the recording of the screen. But since you use the tool for only one developer, you said that you're just recording the screen. The tool is just recording the screen. Do I remember?
Okay.
I'm asking why you turned the video.
Okay. So we were never really. Okay, that's good. So what we had was, we had the Connect sessions recorded in one of the aspects of Jason's thesis, but for this particular part of the thesis, we just were recording the workspace, and we weren't using the Connect cameras in this part. So we didn't show the observers that part. But had we the Connect came later.
To triangulate the data.
Yeah, that could have helped. Yeah.
Well, two questions also. Were there any situations where the people in your experiment disagreed and thought that the person who was working was not actually having difficulty?
You know, it's very interesting. Our tool is very conservative. So most difficulties it misses. But when it figures out something is a difficulty, it's really a difficulty. Okay. And we designed it to be that way because we don't want to have false alarms. So as it turns out, the coders never disagreed with the tool. That just shows that the tool is very conservative.
So the second question I have is, the goal of your system is to sort of essentially be able to offer unsolicited help. Do you have any sense or how you might model whether or not the person with difficulty would like to receive help or would like to continue to persist through their difficulty?
Okay.
Because that's a learning opportunity.
So that's an excellent question. That, you know, do they really want help or not? In this experiment, the developer was not around.
Sure.
The experts just said, could they offer help? This tool has actually been used in the field by Jason in a class that he taught. And there was only one person who didn't quite want help, but was very appreciative that Jason went and reached out to him.
Okay.
So that was a good effect.
Okay.
Otherwise, everybody was very happy to receive the help. And Jason, you know, I mean, he was also conservative when he offered help. So yeah, that's these are all very interesting questions. Get out of the way.
Thank you, Ging.